I'm Anil Kumar sharing with you a question from a student who wants to understand how to solve this kind of a question, which is based on derivatives. A copy of the question is right here for you. Let's go through it. There are a lot of things which we need to read and understand before we get into solving it. Is a water skier wears the dog? That's the heading. The question says that water skiing is a popular summertime activity across Canada. A skier holding onto a tow rope is pulled across the water by a motorboat, as shown here, right? Linda goes water skiing one sunny afternoon. After skiing for 15 minutes, she signals to the driver of the boat to take her back to the dock. That's the dock. Turning in a parabolic path as it nears. So this is the parabolic path shown. If Linda lets go of the tow rope at the right moment, she will glide to a stop near the dock. Let the vertex of the parabola traveled by the boat be origin. So we are given some parameters by which you can find equation of the parabola. So let's go through it. Let the vertex of the parabola traveled by the boat be the origin. The dock is located 30 meters east and 30 meters north of the origin. So this point is 30-30. If we take O as the origin, the boat begins its approach to the dock 30 meter west and 60 meter north of the origin. So we can consider this point to be 30 meter west and 60 meter north, right? So the coordinates will be minus 30 plus 60. If Linda lets go of the tow rope when she reaches point A, where is she headed relative to the dock? Use an equation to describe the path, right? Hint, she will travel in a straight line. Now part B is, if Linda lets go of the tow rope when she reaches point B, somewhere there, which seems to be horizontally aligned with the dock. If Linda lets go of the tow rope when she reaches point B, where is Linda headed relative to the dock? Part C is, if Linda waits until point O, that is this point, how close will her trajectory be to the dock? D is, at what point should Linda release the tow rope to head straight to the dock? So somewhere tangential. Do you understand? So like this, we have these many questions. Then we also have few communication questions related to the situation. The communication questions are, what assumptions have you made? To make the situation more realistic, what additional information would you need? Create this information and solve part D using what you have created. So that's the question for you. It's a small print. You might not be in a position to read it carefully, but still I'd like you to pause the video, copy the question, enlarge, see if you can read, understand and solve it. Perfect. Now let us see how to solve such a question, right? So I'll kind of sketch the diagram, find the equation of the parabola, then find derivatives at different locations. Derivatives will give me slope of the tangent line, then find this equation of tangent line as these points. So that will help me answer parts A, B and C. For part D, which is at what point should Linda release the tow rope to head straight to the dock, we'll figure out a point and let us see how to solve this. Correct? So let's begin to solve the question. Let us now try to understand the question and then we'll solve it. What we are given here is a parabolic path of the boat, right? So it's kind of like this, where the vertex is at the origin, right? So let me sketch the coordinates now. So that is the vertex at the origin. We are given location of the dock, which is 30 east, 30 north. So let's say that is 30 east and 30 north. So that is the equation, that is the position of the dock, which is 30 to east and 30 north. We are given a point A, which is 30 on the west side, but 60 north. Let's say this is point A for us, which is 60 north. And here the location is minus 30. We're also given a point B, which is at the same level as point D, the dock. What do we need to find? 1. In part A, we need to find equation of tangent line at A. So this is first target. In part B, we have to find equation of tangent line at B. In part C, at the origin O. Then we have to find a tangent which will lead to D. Perfect. That is all we have to do. So let's see how to find equation of tangent line at A. First step should be to find equation of parabola itself. Since vertex is at origin, general equation of parabola can be written as y equals to ax square, right? To find the value of a, we can substitute the coordinates of capital A, which is minus 30, 60. Y value being 60, a value being minus 30 whole square. So a is equals to 60 over 30 square, which is 900. And that gives us a value of 1 over 15, correct? 0, 0 cancels and 6 goes 15 times in 90. With that, we get the equation of parabola, and the equation of parabola is y equals to 1 over 15 x squared. So let's highlight this equation. So that's the equation of the parabola. To find the equation of tangent line, let's find the derivative, right? So derivative will be 2x over 15. Now this is the general equation of the derivative. Let me highlight it in a different color. We can also number these equations. Let's number equation 1 and equation 2. Now to find the equation of tangent line at A, where x value is minus 30, what is going to be the derivative? Well, the derivative at x equals to 30, which is point A, will replace x with minus 30 here, right? That is the value of x, divided by 15. And this is equal to minus 4. Since the slope is minus 4, we can write equation of line as y equals to minus 4x plus b. To find the value of b, replace x and y by minus 30 and 60. So we have 60 equals to minus 4 times minus 30 plus b. And rearranging, we get the value of b as equal to, so that is 120, right? So we get 60 minus 120, that is minus 60, correct? And now we have the equation of the tangent line, correct? So let me rewrite the answer of part A here, which is equation of line at A can be written as y equals to, slope is minus 4 x, and the y-intercept is minus 60, right? Minus 60. So that is the part A for us. Now, let us do part B. In part B, we have to find slope of the tangent line at B. Now we know at B, y value is given to us, but we don't know what is x value. So first step is to find the x value, correct? Since the equation of the line is y equals to, the parabola is y equals to x squared over 15. Knowing the value of y, we can find what x squared is. So we could write this as 30 equals to, which is minus 30, of course. We have, 30 is, we need to find the x value. It is 15 times y value is plus 30, and we have x squared over 15, correct? So we'll cross multiply and then square root it. So from here we get x squared equals to 15 times 30, and x is equals to square root of 15 times 30. Whenever you do square root, you get both x and y values. In this particular case, you can clearly see that we are only interested in negative value, right? Not this positive value, right? Because this value is also there, correct? So for us, at point B, we know that x is equal to square root with a negative value of 15 times 30. So I could write 30 as 15 times 2. See, it helps you to find square roots without doing many calculations. So it gets you minus 15 square root 2 as the x value. And therefore, the coordinate point for B now is 15 square root 2, y value being 30. Do you see that? Since we know x value at B, we can now find the derivative at B. So the derivative at B will be, substitute the x value, right? So we have 2 times x value of minus 15 square root 2 over 15. And that gives you a slope of 15 cancels, minus 2 square root 2, correct? So that is the slope of the line at B, kind of like this, correct? Negative slope. Since we know the slope, we can find equation of the line. So line B can now be written as y equals to slope, which is minus 2 square root 2 x plus B. To find the value of B, we can substitute 30 for y, right? We have minus 2 square root 2. The x value is minus 15 square root 2, minus 15 square root 2 plus B. Now that gives us 30 equals to 2 times 15 is 30. Square root 2 times square root 2 is 2, 30 times 2 plus B. Now clearly that is 60. When you take it to this side, we get minus 30 as the value of B. And so we can write equation as y equals to slope minus 2 square root 2 x, and B is minus 30, correct? So we get the second equation, which is at B. Perfect. So we've done two parts, finding equation of line at A and also at B, right? So these are the two equations which we have just found. Now let us figure out part C, which is how far is when the boat is released at the origin. So at the origin, what is the slope? Well, you can clearly see slope is the x-axis itself, and the distance which is between the boat and the dock is this distance. Is it okay? And this distance is 30 units, right? So mathematically, we can say that the slope at origin will be substituting 0 here, right? 2 times 0 over 15, which is 0. And since origin is at 0, 0, the equation of the line is y equals to 0. And distance of D, the dock, will be the vertical distance of 30 is 30 units, right? So I'm not sure whether they are given units. Yeah, the units are in meters, 30 meters. So let's get back to the question. So we have already done part A, B, C, which is if Linda waits until point O, how close will her trajectory be to the dock? Perfect. And the units are in meters, 30 meter by 30 meters. Now we are almost at the end of the question. So I'll move on to a new page to figure out the point from where the tangent to this curve should lead us to the dock. So we are looking for this point now. Okay. So let's move on to the next page and do the last part of this question. We draw the diagram. So it is a trajectory which is kind of a parabola whose equation was y equals to 1 over 15 x square. The vertex is at the origin. Dock is at the position 30, 30. So we're calling this point as the dock. We already found equations at point A, B, and O. Now we are interested in finding a point so that if Linda releases the rope, then she lands at the dock. So that means a tangent line from here should pass through that point. That's the whole idea. So that is the point P which we are interested in finding. So let us assume that the coordinates of this, and the coordinates of this point is 30, 30. That we know this, right? So this is 30 and this is also 30. So let us say, let the point P be, let's call it AB. Is it okay? Now clearly, if x value is A, then what is y value? We can write this point P as A. If I substitute A here, I get A square over 15, correct? So that becomes the y value. Now slope at any point on this curve is 2x over 15, correct? If we have to find the slope at x equals to a, this could be written as 2a over 15. We can also find slope using the formula y2 minus y1. Slope m is also written as y2 minus y1 over x2 minus x1. Now if I use this formula, then slope at point A will be, we are looking into these 2 points, right? A and a square by 15 is the y value, and 30, 30. So y2 is 30 for us. We can say 30 minus y value of a square over 15 divided by 30 minus a. Correct? So this becomes the equation of slope. Now both these slopes should be equal, right? Since they are at the same point, point P, right? Since both slopes are equal, so what we're trying to say here is both slopes are equal, right? That means I could write this as 2a over 15 should be equal to 30 minus a square by 15 divided by 30 minus a. Now we have an equation in a, we can cross multiply and simplify. So we get here 2a times 30 minus a equals to 15 times 30 minus a square over 15. So if you open the back bracket, we get 60a minus 2a square equals to 450a minus 15 cancels. So we are left with a square. Bringing the terms together, let's take them to the right side. So we get 0 equals to 2a square minus a square minus 60a plus 450. Okay? So we have a quadratic equation which can be written as a square minus 60a plus 450. Now it's a question of solving this equation and getting our point A. That is what we are interested in finding. So from here we can write down the value of A using the quadratic formula. So A is minus of B, which is 60, plus minus square root of 60 square, right? So you can write minus 60 square, minus 4AC, A is 1, and C is 450. Let me use a different ink. Divided by 2 times A, which is 2. Is that okay? So that gives us, let's calculate this out now. So we have 60 plus minus square root of 3600, and that is 4 times 450, 4 times 0, 0, 4 times 5, 22, 1800, right? So twice 3600 divided by 2. So we can now use a calculator and find this answer, right? So we get actually 60 plus minus square root of 1800 over 2. Right? So let's figure out what this answer is. Let's calculate this answer, which we have 60 minus square root of 1800, which is equal to something. Let's divide this by 2 to get the answer. In decimals, let's write down answer in decimals, which is 8.786. Now we have taken 8.786 as the value, which can always be rounded to 8.8. If we know the value of A, right, so we didn't add and do because then we'll get a point which is further away, so that is a valid point. B, the y coordinate at this point is equal to A square over 15, that is 8.786 square of this over 15, correct? So let's find square of this number and then divide that by 15. And we get a point is 5.147. Is it okay? So that becomes the B value. So anyway, we can round them to 8.8 and 5.1. Let us see. So that becomes the point where when the rope is released, Linda will straight go to the dock, right? Since the tangent connects it. So that is how we can actually solve this particular question. Now, other parts in this question are what assumptions have we made and what could be a realistic situation, and we may add those things and then further solve our question. Well, the assumptions which we have made is that speed is maintained all along, constant speed. So as far as assumptions are concerned, you can say that constant speed is maintained. And another assumption could be that there is no frictional force, kind of air, right? So we are saying air or water friction. Water friction is of course there, which helps you to water waves, I should say, right? When velocity is neglected. So we are assuming that it's not a windy day. We are assuming that there are no waves in it, right? So there are these assumptions which we have taken care of, leading to this kind of a result, correct? So I hope that helps you to understand how to solve such a question. Feel free to write comments and share your views. If you like and subscribe, that'd be great. Thank you and all the best.